Your phone says 20%. 10 minutes later, it is dead. Here is the strange part. No sensor in that phone ever measured 20%. That number is a guess. A careful estimate of something we cannot see. This is Chapter 1. What a battery model is, where we use it, and why. Let us start with the thing itself. A single battery cell, welded shut. You cannot open it while it is working. From the outside, you can measure exactly 3 things. Voltage at the terminals, current going in or out, temperature on the case. That is the whole conversation the cell will have with you. But the things we care about are hidden inside. How full it is, the state of charge, how hot the core is, and how much life it has lost, and whether anything dangerous is starting. And state of charge cannot be measured directly. So we build a bridge. From the 3 numbers we can see to the ones we cannot. That bridge is a model. A simplified stand-in that predicts the inside from the outside. Now, where do we actually use this? One place is inside the device, in real time. That is the battery management system, guarding the cell every second. But that is only one use. Long before a battery is built, engineers simulate it in software, testing a fast charge or a whole pack with no lab at all. Others ask economic questions. How many years will it last? What is it worth? And safety engineers ask what fails and when. A phone, a car, a power grid. All of them lean on models for very different questions. And here is the key idea for this whole course. There is no single battery model. The management system needs one simple enough to run every second. Research needs one detailed enough to trust. You choose the model to fit the question you are asking. So why not just make one perfect model and be done? Because what is inside is genuinely complicated electrochemistry. Ions move, react, and pile up at surfaces, and it all shifts with temperature and age. We cannot fully capture that, so we approximate. Deliberately and honestly. A model is never the cell. It is our best honest stand-in for it. So here is the plan. We build models from dead simple, upward, adding pieces only when the question demands it. Each one useful, each one wrong in its own way. The simplest useful model is a single component, a resistor. Next chapter we start there, one resistor for a whole cell.